Okay. So I squared times I squared is I to the fourth. So therefore, what's I to the fourth?
1.
1. How come? What's I squared?
-1.
Times
-1.
is
1.
good. That's 1. Pretty easy, huh? I've got a question. True? Is that true? So what is it? I to the 6th. Is that true? I to the 7th, I to the 8th. That's the eye chart. It has a recurring pattern after 4 of them, which means how do I know that fast? I divided it by 4 and took the remainder. What's 49 divided by 4? Goes in 12 times with 1 remainder, right? If the remainder is 1, it will always be I. So divide by 4 on the exponent. If the remainder is 1, so divide exponent divided by 4. If the remainder is 1, it'll always be what? It'll always be I. If the remainder is 2, it will be what? -1. If the remainder is 3, it will be what? -I. And if the remainder is 4, you've done something wrong. But if the remainder is 0, you get 1. Because if the remainder is 4 and you're dividing by 4, you've done something wrong. So, but if the remainder is 0, then it's just 1. Okay? So, try this. What is it? 1. 4 goes into that evenly. Okay? What's that? I. What's that? -I. Why? 19 divided by 4 is going to be 4 times with the remainder of 3. If the remainder is 3, it matches the -I. How about I to the 46? It's going to match I squared. It's -1. Everybody got it? Is that very hard? Not very hard. Okay. Is an I a square root? Is an I a square root? Simple question. Yes or no? Is an I a square root? Yeah, an I is a square root. Can I have an I in the denominator? No. How do I get rid of it? I get times by an I. An I for an I. No tooth for a tooth though, because then you can't eat anymore and that would be bad. I times I, what is it? I squared, which is what? Oh no, that's not right. Because if I times the bottom by an I, I gotta times the what? Top by an I. What is it then? -2I. How come I have a -2I? Because the bottom is going to make -1 times the top by an I also. That's the 2I. So it's -2I. Everybody with me on that? It's kind of tricky. Okay, how about this? Yes. I'm going to multiply the denominator by 4 minus I. How come? It's a root. We got to use a conjugate to get rid of a root. The conjugate is what I'm going to use. So yeah, I'm just going to times this by 4 minus I. But if I do that to the bottom, you gotta what? Do it to the top. Okay, let's multiply the bottom out. Now, some people on the test did this a little wrong. They thought that when I multiplied by conjugate, it just went away. Does it go away? No, you have to multiply it out still. So I want to multiply the first terms. What do the first terms multiply to be, Simeon?
16.
The inside and outside will cancel, right? The inside terms and the outside terms will cancel. But I still need to multiply the last terms. This is the tricky part. So what is positive times a negative, I times I? This is tricky. Positive times a negative, I times I. What do you think it's going to be, Mrs. Carter?
Negative I?
Nope. Yes.
Yeah.
No. No.
Okay.
Now you could say it's negative I squared, but I squared is what?
Negative one.
Yeah, anytime you start squaring, you're the negative one. So quit your squaring. You're the negative. It's hard to tell jokes with a mask on. Just say it. All right, I squared is negative 1. Negative times a negative is a positive 1, actually. Because I squared, you're the negative 1 if you're the I squared, right? You can't be squaring like that. That you become the negative 1. So quit your squaring. But a negative times a negative, that turns that smile right upside down. Or, frown upside down into a smile. Got all mixed up there. 16 plus 1 is what? 17 is the bottom. A lot of kids mess that up. They think that the bottom just goes away. It doesn't go away. It's the first terms, which will make 4 times 4 is going to be what? 16. And then the last terms is negative I squared, but I squared is negative 1. Negative times negative is a positive. Positive 1, 17. Okay? What do I got to do on the top? Well, on top, I would just distribute it so that it's in A plus BI form. This is 12 minus 3i. By the way, you probably want this in your notes. A plus BI, plus or minus BI, A plus or minus BI is called complex form. Okay? That means there's a real part and there's a what? Imaginary part. Okay? There's a real part and an imaginary part. Now let's talk a little bit about the graph really quick. This isn't even on the assignment. This is just so you understand why we're doing imaginary roots in the first place. Let's say I had this equation. Really simple. Okay, how would that graph? Think back a chapter or two maybe. How does that graph? 4 above the what? X-axis. Everybody agree with that? Yep, I'm just going to go up 4. And then, 4. Let me do that again. So we're going to go 1, 2, 3, 4, so they're evenly matched. Okay, and then what am I going to do from there? I can follow the parent graph. I'm going to go over 1 and up what? 1, because the A value is 1. So I'm going to go over 1, up 1, over 2, up what? 4. Yep. So this isn't very hard.